Are you ready to do jobs with multiple bits and make some cool projects? Well, let's get stuck in. We're in the office and back at the computer, which means one thing, a Carveco Maker tutorial. Now, if you are new to the channel, obviously the first thing is to make sure you hit that little subscribe button in the corner to get all the latest reviews, tips and tricks, and of course tutorials like you are watching now. But more importantly, it's just a reminder that this is part of the Carveco Maker Beginners series. There are a few episodes that came before this where we run through things such as setting up your software, the different tools available, and obviously the type of terminology that you may expect to hear as part of doing these type of software and tutorials. Now, the purpose of today's video is obviously to do a job that requires multiple bit changes, because ultimately, well, this is the foundation to doing most CNC jobs. We're going to start by doing a simple bowl, but this is basically got a nice chamfered edge, a rounded inner edge, and then a nice smooth cutout around the outside. But ultimately, once we've learnt these skills, they're transferable to make lots of different things, such as serving boards, cutting boards, flight boards for drinks, signage, lots of different types of items that ultimately you can use to make and sell as part of your CNC project. So let's move over to the software and get stuck in. So I'm doing something slightly different, and we're actually going to start right at the end so you can get an idea of what we're going to achieve and the different things we'll be doing to make that happen. So the first thing I'll point out is we'll see these nice chamfered edges on the inner and outer of the bowl itself if I turn on the path line for those. And you can just see it takes the edge off the bowl, making it a little bit softer. Then on the inside we have this nice rounded corner on the inner edge, obviously to make it easier to get things like coins out. And what we can see as I turn that on is we've got these little arcs going on at the top. These are called lead in and lead out passes, and I'll talk you through these as we go through the video. But just make sure that your inner edge, when it is cut, has a nice smooth finish. Then we pocket out the entire middle of the bowl itself just to get rid of all that waste material that we don't need. And then ultimately we have the outer cut around the outside, obviously to cut out the bowl itself. And again, we have these little lead in and lead out marks over here on the bottom right. So if I turn all those back off for now, and ultimately this is the bowl that we're going to produce. So let's show you how we do it. So the first thing we're going to do is create a new model. We'll go File, New, Model. And we'll put the dimensions in. We're going to make this 140 millimeters wide, 140 millimeters high, and we're going to leave the resolution at full. We'll also leave the center for the job origin and click OK to create the model. Now it loads up in the 3D tab, but you can always switch to the 2D tab if you prefer to work in there, as we are going to begin drawing initially. So I'm going to come over to the circle tool. And what I'm going to do is create an initial circle with a radius of 60 millimeters, so an overall diameter of 120. I'm going to hit enter and make sure that it is permanent. We're then going to create a second one with a diameter a little bit less. So I'm going to make this 47 millimeters and hit enter and click create. So now we can see we have our two circles in the center of the screen. Just to be safe, I'm going to highlight both of them together by clicking and dragging from the right hand side over the shapes, and then hit F9 just to guarantee that they are in the center. They should have been anyway because the X and Y position was at 0, but it is just to guarantee they sit in the center of the screen. With both of them selected, the first thing we are going to do is that chamfered edge around the outside, as I say, just to soften the appearance of the bowl. So we're going to come up to toolpaths, and we're going to select the profiling toolpath. Now for the chamfered edge, we're going to want to perform this toolpath right on top of the line itself. So where we have the profile, we're going to change this to along. Obviously you have inside, outside and along. Along means it's going to follow the exact line directly on top of it. The start depth for the job will be 0, and the finish depth I'm going to put at 2 millimeters deep. Now the reason for this is you don't want it to go too deep. We just want a very gentle chamfer on the edge. Obviously if you want more of a chamfer, then set the finish depth to a deeper depth at this point. We're going to leave tolerance as it is, and then we're going to go into the tool selection menu, and I'm just going to go and find one of my 90-degree V bits. that one will do. Click select and load it in. Now, as in previous videos, I am not going to drill down on the speeds and feeds too much because this is all relevant to your machine and setup. So for now, I'm just going to leave these default values in and work past this point. Earlier on, I mentioned about lead in and lead out paths, but for this particular job, we don't need them. I'll explain a bit more about them as we get to the other paths. We will, however, turn ramping on. This just eases the bit into the material as it starts to cut and ultimately extends the life of your bits. I have mine set up to do a bit of a zigzag pattern, and these are the settings I'll be using. A maximum ramp angle of 20 degrees, no longer than a 10mm ramp length, 0 minimum ramp length, and a height of 1mm. So that basically means it will start the ramping process at 1mm above the job. Now you can make this a higher number to be safer, but ultimately it extends the length of your job. So you kind of want to keep this to a minimal number, let's say, to make your job as efficient as possible. We don't need any bridges on this particular path, but what we do need to do is come down here to define the material thickness. Now once you click on this menu will load up, and we are going to be working with 40mm thick wood today. So I'm putting 40, click OK, and that will basically set the depth of our material. Now we're going to name this path as chamfer. What I don't normally do recommend is when you are doing your toolpath, put some useful information in to help yourself. So for example, in this one, we may put chamfer 90V bit. Then we're going to click calculate and generate that job. Now obviously we can see the lines have changed colour to show that there is now a toolpath here, and if we wanted to see that, we could go into the 3D view. We can obviously see the toolpath and the outline, but we can then simulate this by right clicking on toolpaths and coming down to simulate all toolpaths, and we can simply see there are the chamfers that we have just done. Now I'm just going to stop there a second. There is a fairly common saying that goes, there's more than one way to skin a cat. Not a great saying, but what it basically means is there's more than one way to do a particular job. Now the reason I'm telling you this is because I'm going to show you the most efficient way in my head to do the next part of the video in terms of machining out the middle of the bowl. But ultimately, different people will approach it in different ways. And in fact, I asked it in the Carveco user group, and I got about 7 or 8 different approaches to machining everything out, depending on whether you want to do it in 1-bit, 2-bit, 3-bit, and ultimately the different ways people approach the job. Now, I'm just simply telling you this in case you want to try something different. Then go ahead, have the confidence, and maybe find your own approach as to how you would machine the middle of the bowl out and leave the rounded edge. But let's get back to the tutorial. So what we're going to do is come back to the 2D view, and what we can also see here, obviously pay attention to the color of the lines. It's because the toolpath is still highlighted. If I turn the wireframe visibility off for this, it will go back to being black lines. It is a subtle difference, but it's basically the difference between selecting toolpaths that have already been created or the original vectors. So we're going to now highlight the inside one by clicking on it, and we'll see it selected going to this pink purple color. We're going to go back to the toolpaths, and we're going to come down to the profile toolpath again. Now in this scenario, we want to machine the inside of the toolpath, so we'll drop that down and go to inside. We're going to leave sharp corners unticked, and what we can see here is it's remembered my previous settings from when I did this. We want to leave a final pass thickness of 1mm. What this basically means is that it's machining through the material, it will make sure that the last pass that it does is no thicker than 1mm in terms of the depth when it is cutting. Next we have final pass allowance. Again, we're going to leave this ticked, and this is 0.2mm. Now what this means is as it machines around in a circular fashion, it will do every single pass 0.2mm narrower than it should do. Then on the very last pass it will go a little bit wider, and it will ultimately give it a much cleaner finish all around the inside of the edge. We're going to come to the start depth, and again that will remain as 0, but we're going to make the finish depth of 32mm. Now you will remember the depth of the material was 40mm. That means the thickness of the base will ultimately then become 8mm. We're going to leave the tolerance as it is as standard. We're going to come down to the profiling tool to select it, open up obviously the tool database. Then I'm going to scroll through my menu just to try and find a bull nose bit somewhere here. This is one of the ones I want, a 1/4 inch diameter bull nose bit. So we're going to select that. And again, just to reiterate, I'm not going to touch too much on the step overs and the step down speeds because it's all relevant to your machine and your setup. But what we are now going to do is add a lead in and a lead out. Now, I briefly touched on this earlier on, and it is about making sure that you have a much smoother cut when you're starting to do things like profile cuts. And what it will do is, instead of cutting right on the line, so to speak, it will start outside of it and bring it in nice and gently. Now, you can either do this with a linear line, and this will be a straight line into the cut, or you can do this with a circular arc. I much prefer to do it with a circular arc, so I'm going to select that, and I'm going to put a radius on it of 10 millimeters. Now I'm going to leave automatic positioning on. You may find this can sometimes cause an issue with certain jobs, but for the most part, automatic positioning allows Carveco to select what it believes is the best point to start it. We're going to turn ramping moves on again, and it remembers my previous settings, which I'm completely happy with, and obviously the material thickness has now already been set. So what we can just do is call this rounded profile. Now when I click calculate now, we'll obviously generate the toolpaths, but we should see two little arcs start somewhere on the inside of the toolpaths, which will be the lead in and lead out. There we can see it's generated them down towards this bottom right hand corner. And you will remember earlier I mentioned about the final pass allowance. If we zoom right in, what we can start to see is there are two offset toolpath lines. The inner one will be the normal toolpath that it is cutting, and then the outer one is that extra 0.2 allowance that we did for the final pass, just to make sure we get a much smoother cut. And again, what we can do is go over to the 3D view. We can simulate both of these toolpaths together, and we can see how far we've got up to. So what we can see there is the lead in and the lead out starts out in the inner of the circle. We'll ease in nice and gently, do all the profiling, and then ease it back out at the end, as say to minimize any tool marks on the material itself. We'll go back to the 2D view. I am switching back and forth here, as obviously you can do it all in one particular view if you want to. Now we still have that vector selected. We can see that by the color of it being the pinky purple. So what we are then going to do is come to the area clearance tool. Now at this stage we're going to machine all of that middle material, effectively leaving us with a hollowed out middle after we've just put that rounded profile in. So for the vector selection, we're going to leave it as selected vectors. As start depth, we are going to leave it as 0. The finish depth, we are going to do the same as the last pass, which was 32 millimeters. Now this is the part that catches everybody out. The bit we're machining has already had a good chunk taken out of it by this profiling pass, so we don't need to do that again. Also, we're about to use a flat end mill, whereas this has just been machined with a radius bit. So if we did exactly the same with a flat end mill, we'd end up having a really sharp corner, and we don't want to go over that. Now there are potentially two ways to deal with this. We could have drawn another circle on the inside just to do the area clearance part, or we can use the allowance feature within it. Now to work out the allowance we need, you ultimately need to know the radius of the bit that you just used for that profiling rounded cut. Now the bit diameter was 1/4 inch, so the radius therefore will be 1/8 bit. Now if you're doing that in metric as I am, that is 3.175. Now what that will do is factor in that allowance on both sides of the circle, so the bit just machines inside and doesn't touch that radius part that we'd previously created. It's kind of difficult to get your head around initially, but once I simulate this you will see the difference in what I mean. For the final tool allowance, again we're going to make this 1 millimeter. I just always like to make sure that the final pass is as minimal as possible to save roughing too much material out. In the tool list we're just going to use a good old 2-flute end mill just to hog as much material out as possible. Let me scroll through my list and find my normal 2-cut end mill. There we are, we'll load that in. And again skip past the speeds and feeds. Now for the tool clearance strategy, this will make a difference depending on what type of material you are using. Obviously we're working with wood today. Wood has a grain, and you will always want the raster angle to go with the grain of the wood. So in today's scenario the grain is running from left to right or right to left, so we're going to stick with the raster option. Now if for example you rotated your wood around and the grain was running front to back, you could always rotate the raster angle and put that to 90, and it would just reflect at the same angle that we are machining at. But because the grain of my wood is going left to right, we will leave it at 0. We will turn on ramping moves again, and leave all the settings as default. Then we're just going to come down to the toolpath name at the bottom and go pocket. Click calculate now. Now this is what I was trying to explain earlier. It has factored in the allowance. We can see the outer circle that it has just generated now sits within the original toolpath of the rounded over bit. So what we can do is when we simulate this, neither of those two toolpaths should really interact with each other. So if I right click and we simulate all toolpaths, now what we can see is if I rotate this round, we've got this lovely curved edge, but there's no interaction between the part that we have just machined out. If I turn the actual toolpaths on for that job, hopefully it gives a better indication of what I was trying to say. So we can just see there's a big clear gap around the outside to save it interacting with that radius. Now, purely just to make my point and stress this, what I'm going to do now is turn that allowance off that we had factored in, and you will see the difference. If we set that to 0, calculate now, it will ultimately make these lines around the outside go even wider. So calculate, resimulate all of these jobs. And now if I zoom in, we've got a squared edge again. It's just cut into the piece of work that we originally done for rounding that off. That is not what we want. I've purely done this just for simulation to show you why we need to factor in that tool allowance. So we'll put the 3.175 back in. We will recalculate it, and then ultimately we will resimulate the whole thing just to show where we are up to at the moment. So earlier on I mentioned about there being different ways to machine this particular part. Now the reason I did it my way, as I say, was based about efficiency to minimize the amount of tool changes. What some people may like to do is machine all the inner part out first, then go over to the rounded bit to put this rounded edge back in, and then go back to the two flute ultimately to do the profile cut that we're about to do. So basically that means 4 total tool changes. But doing it my way only has 3 tool changes and therefore minimizes the risk of obviously any complications. Now I am going to quickly point out that machining the middle out probably could be done even easier using a 5mm radiused bowl bit, which has radiused edges as well as a flat bit on the bottom, so we can sort of do it all in one. The reason I'm not doing it that way is because, well, they're not a common bit that everybody has, whereas the bits we're using today, a flat end mill and a ball nose bit, are much more common, and that's why I'm showing you how to do it with those particular bits. Now the final thing we need to do is the profile cut around the outside, obviously to cut the entire bowl out itself and make it finished. So again, we'll come back to the 2D view, but this time we want to select the outside vector for the cutting, and again it's showing the right vector because it is selected in purple. We're going to come up to toolpaths, and then we're going to come back down to the profiling toolpath. Now for this we want it to cut around the outside of the bowl, so we will leave the profile on outside. We don't need to factor in any allowance. We're going to leave the final pass thickness as 1 because, as I say, I always like that last cut just to be pretty thin to minimize any risk. And we're also going to do a final pass allowance again like we did earlier, just to make sure that final cut all the way around the outside leaves it as smooth as possible. The start depth for the job will be at the top of the material at 0 as always. The finish depth though, we want to make sure we cut all the way through the material. So the material is 40mm deep. We want to make this something like maybe 40.2 or 40.4 depending on how safe you want to be. We will leave the tolerance as it is. And we're going to come back and select that same tool that we were just using, the 2 flute upcut bit. One thing I should just stress at this point, obviously if you are cutting through material this deep, such as 40mm deep, you need to ensure the bit you are selecting can cut that deep. If not, then you may need to purchase a longer bit to do this, or ultimately work with thinner material that your bit can handle. Also, I've used an upcut bit here. People may use a downcut bit if they're worried about their material splintering on top, as a downcut bit will leave a nicer finish on the surface. And for the 4th time, we will ignore all these standard speeds and feeds because those, as I say, are all relevant to you, the user. We are going to add in a lead in and lead out again. It will default back to linear, but I want to make it a circle arc like we did earlier, and again make this a radius of 10mm with automatic positioning. We're going to turn on ramping as well for the same reason as already mentioned, just to ease the bit in, and it's got my default settings in there. Now one thing we haven't done yet is use the bridges feature. Now this will leave little tabs all around the outside holding the material in place. Now depending on how you hold your material down, whether you use clamps, blue tape or CA glue, you may not necessarily need this particular option. But I just like to leave tabs on because say once we cut through, it just means the middle piece of the material will remain in place and therefore a little bit more secure. So we're going to turn add bridges on and scroll down a little bit. Now there are lots of different options in, and sometimes the best thing can simply be to play about with them and see the differences between them. There are options like constant number, adaptive spacing or constant spacing. Obviously constant number will mean a certain amount of tabs all the time. Adaptive spacing will adjust it to what it thinks is best, or constant spacing will use constant spacing to decide how many it can actually fit within the space we are working. I'm going to leave it on constant number for now with a circle. That should mean there's one every quarter, and we leave it at 4. I'm going to make the length of them 10 millimeters. I'm going to make the thickness of them 3 millimeters. I prefer to use 3D bridges. You can use more classical 2D bridges, but I find the 3D bridges just leave a softer finish on the edge of the material, and I'll leave this last option unticked. Now when I click add, it should put multiple tab points around the outside of the job. And we can see that illustrated by these little marks going on now around the outside of the material. Again, we don't need to edit any of these final options because they've already been preset, and we'll just call this the profile cutout, and then we'll generate the toolpaths. If I zoom out slightly, we can see the lead in and the lead out is generated up here at the top of the material. And ultimately, if we do what we've done previously, go over to simulation, right click, simulate all of our toolpaths. What we can see is we've got the lead in and lead out going up on here at the top of the screen, and then ultimately we can see the 3D tabs that have also been left in, which just guarantees that the inner bowl remains in place while it is doing the rest of the job. Now for the most part that is everything done. We have our bowl machined out, but let's just make it look a little bit better. With simulation selected on the right hand side, we can come down to the simulate material and we can look for something that maybe looks a little bit nicer, such as maybe a medium oak. Select that, click apply, and it just makes it look a little bit more realistic in terms of cutting it out in material. Now as I said, for the most part that is your bowl done. We've generated all of the toolpaths, we've included multiple bit changes in this, but the final step is obviously to make sure your toolpaths are exported correctly. So we're going to come back up and select toolpath. We're going to come down to the save option. And what we can see here is actually there is more toolpaths generated than what it appears on the right hand side. So on the right hand side, we generated 4 toolpaths, but in here we have 6 toolpaths. Now what you will notice is that some of them are doubled up. The ones that we added a final allowance pass on, you will see that it has an LP for last pass. So what you can do is simply export these as separate toolpaths if you want to run them separately, or you can combine them both together in order to allow it to run in one single pass. What we'll do is shift all of these over to the left hand side, and I'll quickly run through how I export these out. So the first thing we'll do is select the beginning job, which is the V groove, transfer that over. And then we're going to select the relevant folder to save it in. I've got the folder that I did previously called bowl, so I will select that. And then I'm just going to give this a name. Now when I'm doing multiple bit changes like this, for ease I try and use some sort of naming convention. So this is the first toolpath that needs to run, so I've called it number 1. It is a 90-degree V-bit and therefore I've put that into the name, and this is for the chamfered edge, so again I've put that into the name. So I'd then go save. I'd then take that one back over to the bottom of the pile. Next we're going to do the rounded profile. So we'll select both of these, move them across, and you do just want to make sure that last pass is the second one that runs, so that should be at the bottom of the pile essentially. And again we do a similar thing, so we're going to call this number 2 ball nose inner profile, and again we would then save those out together, take them back over to the opposite side. Now the next 3 toolpaths are all done with the same bit, so we can drag those over together, transfer them across, and again just making sure that they are in the order that we need, with the LP pass being the last one for the profile cutout. Now technically you could export these out as separate jobs, do the pocket first then the profile cutout, but as I say, because they are all the same bit, they can be ran one after another without any issues. So what I'm going to do is put 3 and 4 upcut, pocket and profile, so I know what they're going to be, and click save. Then we can close this down. And there you have, that is the job complete. We have generated a bowl, we have used multiple bit changes to achieve this, and we have exported all the toolpaths out in the correct order that they need to run. All that is left to do is move over to your CNC machine and set the job up, ready to be ran. So we've gone full circle. We now have a finished design, except you can create this from start to finish. And remember, this is the base for creating lots of types of different projects. So go ahead, experiment, play, see what you can create. Now, after actually doing the G-code and setting everything up, one of the more difficult parts is learning how to change your bits and keeping the spindle consistent and always guaranteeing the start position is the same. Now, if you are struggling with this, which can be difficult with smaller powered CNC machines, definitely check out my video for setting up your Z correctly and doing some basic steps such as homing your machine first and noting the coordinates before you start any job. There will be a link up in the corner to follow that video and talk you through all the steps, as I say, for best practice. Thank you very much for watching the video. If you enjoyed it, please give it a thumbs up. Please make sure you subscribe. It always helps the channel. Final thanks as always goes to my patrons. If you want to get involved for one-to-one help, giveaways and early access to content, then check out those links as well. I will see you all on the next episode.